have, at the previous conference in Europe, we've got a whole track related to other semantic wikis. And here we have the talk of this sort, wiki for modeling and modeling ontologies called MoKi. And Mauro will talk about that.
Yes, thank you. So good morning to everybody. I'm Mauro. I'm a postdoc at the Fondazione Bruno Kessler, that is a non-profit research institute located in Trento. And this morning I will present you the work that we have done on developing this tool for modeling processes and ontologies in integrated manner. So what I will try to do is to give you a general overview of the work that we have done, because I don't have enough time for going into details of the tool, so I will start with the motivations that lead us to the development of this tool, the main pillars that are behind the architecture that we have implemented, and also I will show you the main features of the tool. So feel free after the presentation to stop me at the lunch, at the coffee break, by mail, via Skype, everywhere, for asking me details about this. So, at the beginning, the reasons that will lead us to develop this tool is that we want to provide something that permits to model processes and ontologies in integrated manner. Because if we want to try to model an organization, what happens in an organization, we have to model both the processes that are present in the organization, and also the documents, for example, that are used. Moreover, we want also to permit to do this in a collaborative way, because we know that these kind of activities are done by a team play, in a team play way. So why we want to do this? Because when we model, for example, an organization, we need to model both the dynamic part of the organization, that is represented by the processes of the organization, but these processes are connected also with a more static part that is modeled through an ontologies. For example, the documents, the relationships between the documents, the relationships between the activities and the roles of the organizations, and also the relationships between the documents and their structures. And also the collaboration part is not, we're not seeing this collaboration only as an interaction between people, but also between people with different competencies. Because we have, for example, the domain experts, that are the people that has a deep knowledge of what happened in their domain, but generally they are not able to formalize this knowledge in with formats like, I don't know, OWL, logic axioms, and so on. And also we have the domain experts that are experts in the formalization of the knowledge, but generally they don't know what happens into the domains, into the organizations. Here we can see, for example, a BPMN diagram that explains what happens during the process revision of a paper in a conference. We can identify 3 different swim lanes in which we have the different actors, and also the activities and the documents that are present in this process. So here we have the modeling of the dynamic part, because we have the modeling of the process. But into this process we have also some static entities. For example, we have the roles, okay, that we want to model, because, for example, for each role we want to formalize the limit that they can do only some actions, and that they are able only to work on some documents and not on the whole set of the entities. Then we have the documents, paper, the camera ready, the review, that also have their structure, and that also they can be manipulated only by a precise set of users. And also we have the tasks, that are the single actions that are performed during the process, that, for example, provide changes only on some documents and with in a precise way. So the research vision that is behind the tool is that we want to model this process and the processes and the ontology behind the domain. And for doing this, we have defined this theoretical framework in which we provide a formal representation of this integration, and also we have provided an architecture for the collaborative conceptual modeling on our domains. So the tool that we have developed, that is called MoKi, the modeling wiki, permits to the different kind of users to perform this action by exploiting the collaborative architecture and also the formal representation of the elements. So today I will not go into detail of the formalization of each aspect of the tool. So I will show you briefly which are the three main pillars that stay behind the architecture. So first of all, in our tool that is based on Wiki, because it's built as an extension of MediaWiki, we associate each page of the tool to each entity of the domain. For example, here, if you want to put in our domain, in our model, the concept mountain, we will create a new page called mountain, in which we'll put a description of it. Moreover, we want to provide in each page not only the unstructured description of the entity, that is the textual one, but also we want to provide a structured definition of each concept. For example, here for the mountain element, we can see the textual description of the entity and also a formalization by using logical axioms. Okay, and all these elements are put in the same page of the MediaWiki. The last pillar is the different views to access this kind of information, because as I mentioned before, we want to provide something that permits to people with different competencies to work on the same entity. So we have this unstructured view that permits to access to the textual description of the entity, a semi-structured view that provides some templates for editing some basic relationships of the entity with respect to the model, and also a fully structured view that is dedicated to the knowledge engineer, in which they are able to formalize with logical axioms the relationship between concepts. The goal is to support collaborative scenarios like this. For example, here we can see that we have several actors, the domain experts, the knowledge engineer, and also in some cases in a multilingual environment, we can have also language experts. A domain expert adds a new concept to the domain. It starts a discussion with the other domain experts that are supported by the knowledge engineer for support the formalization of the concept. If we want to make our model available in several languages, we can decide to automatically translate labels and description of the concept in other languages, and in this case we have other kind of actors, for example language experts, that are in charge of validating the translation of the concept. Okay, because in some cases, obviously, if you automatically translate a label from one language to another, we need also to verify if the translation is adapted to the domain that we are modeling. So now let's go to show what we have implemented in this tool. So in general, MoKi, okay, I've already mentioned that is based on MediaWiki because it's been an extension of it. It supports the formalization of this model and provides all the mechanisms for supporting this collaboration between the different kind of users, and also is based on the architecture that I've just presented. Now I have a series of screenshots just to see what we have. The unstructured view that, as you can see, is the classic view of wiki pages, in which you can write the description of each concept. Then we have the semi-structured view that is the real core of MoKi, because this view can be customized based on the domain that we want to model. For example, here we have the general version of the view. For example, we have the possibility for domain expert to specify the is-a relationship, the part of, also some basic properties, and there is also another block that permits to visualize in a natural language the axioms that are provided by the knowledge engineer. And then we have the third view, that is the full instructor view, that is dedicated to the knowledge engineers, that permits to specify logical axioms by the knowledge engineer in a LaTeX-like language. Okay, and these axioms, this view is aligned with the semi-structure one. So if the knowledge engineer writes some axioms here that are not supported by the visualization of the domain expert, these axioms are automatically translated in a natural language and shown in the verbalized part. The result is that in our wiki page we have the wiki description of the entity, and also we have injected the OWL representation of each entity, where the alignment between the access mode and the wiki pages is linear for the classic description, and for both the fully structured description and the semi-structured one, the information are directly read from the OWL representation of the page and shown in the different view. And all these views are automatically aligned. Okay. The same happens also for the processes. We have the unstructured view in which people are able to write the description of the process. In MoKi, we have integrated the Oryx editor for designing the processes by using the BPMN notation. And in the lightly structured view, we have personalized the stencil set of the elements by providing only the elementary elements. For example, the start, the end, the task, and generalized gateways. While in the fully structured mode, we give the opportunity to design the process by using the entire stencil set of the BPMN standard 2.0. And also in this case, when a knowledge engineer formalize the entire process by using the entire stencil set, if a domain expert would like to see the process without all this rich information, the the lightly structured view is automatically aligned. Okay, so I will go very fast on the further features. There are also the possibility of editing the ontology by using graphical elements. Graphical tools. We have implemented a key concept extractor from text corpus for boosting the editing of the ontology, because if you want to enrich the number of concepts in our ontology, we can analyze text of a particular domain in order to have suggestions for a new concept. Then we have implemented the support for multilingual management. MoKi is equipped with a connector that can be customized for connecting with also domain adapted language services and other public machine translation services like Microsoft Bing. We implemented there is a series of connectors for tools that can be plugged to MoKi. For example, automatic suggestions of mapping between different ontologies. A component for managing the evolution of the ontology and keeping traces of the changes that we performed on the OWL code. And exposure services for publishing the ontology that you developed in MoKi in linked open data format. Connector with triple stores and also a connection with the possible SparkQL endpoints for performing queries on external data sources. Then I have a series of slides concerning the projects in which MoKi has been used. The APOSLE project is the project in which the tool has been developed, that was dedicated to the modeling of tasks and processes in enterprises. So it was a very interesting project in which we can verify the usefulness of disintegrating modeling between processes and ontology. Another project, the Pescado project, in which we built this ontology about environmental, and we exploited the key concept extraction for boosting the creation of the ontology. In this organic EduNet organic lingua project, we implemented the multilingual support for translating the ontology. In this national project, we provided some we have customized the tool for supporting the modeling of the public administration processes with the goal of trying Italy to dematerialize the procedures. And in another project with the local healthcare in Trento, we have customized the Oryx editor with the ASBRO standard for defining clinical guidelines for the breast cancer cure. And in this ongoing project, Promo, we are doing this first attempt to link models with data. And it is an ongoing project that is going also to end at the end of the year, and we have connected the models designed with MoKi with a data repository for analyzing the traces of real processes. So I had also this couple of slides of the evaluation, but I will skip it. But in very, very brief, we also performed an evaluation of the tool because, okay, we know that wikis are useful because permit collaboration and so on. There are several interesting features, but we also performed an evaluation in a real-world project for the perception that the users had about the tool, about the usage of wikis, and everything went well. Okay, I will not go into details. The project the tool is ongoing because we are always a lot of stuff to do on it. Here a brief set of future work and things which we are working. So okay, some resources. Publications about the tool, the first version that is online, a new release will come at the beginning of the next year, and this is the URL of the website in which you can find something, but if you are interested in it, I suggest you to contact me by mail so I can provide you the last version, support via Skype, you can do something, a call, demo, training, everything that you want. Okay, thank you.
Thanks. Are there any questions? Yeah, Lloyd?
Interesting talk. Thank you. You model in OWL and perhaps also RDFS, so if at least it exports it. How much of RDFS and OWL do you cover? And what your models?
The standard, OWL 2.
Excuse me?
The OWL standard. We have an internal component that transform the information that users put on the mask in OWL axioms.
Okay.
Okay. And
so my next question is, OWL causes a lot of particular inferencing to occur. And what's nice about this type of system is, well, I'm looking at from a model-driven approach, where you have users enter the data model, but also see what the consequences of the data model are and how the system behaves. Do you show some of the quirky inferencing that OWL enables?
There is the possibility of attaching the reasoners in order to have advice in case of inconsistencies and so on. Yeah. But MoKi with the tool does not come with a reasoner integrated because we have seen that everybody has his preferences in using reasoners. Someone using pellet, someone using other things, and because the results are quite different. If you try, for example, we tried in Protégé, we tried with the BPMN ontology. With the BPMN ontology, we tried to perform some evaluation on the reasoner because we had to decide some years ago which reasoner to implement in Protégé, and there are some cases that are not detected, some inconsistencies that are not detected. Now I don't have the details, but if you're interested, I can provide you the test. Small things, but not. Obviously, the basic ones are always recognized, but there are some cases that the pellet recognize them, and don't remember the other one. inconsistencies.
Oh, okay. The inferencing itself is interested, and that is.
No, the inferences, okay, are performed by it, but we in the current version we not provide any reasoner already integrated with the tool.
Okay. Other questions you can ask in the coffee break, and now we have a talk which was switched with Yolanda's talk by Wojtek. He is going to talk about very hot topic for